All right, kids. All right, everybody. We're going to jump into a Desmos activity. And the Desmos activity, you can do it at your own pace, and I'm going to show you how it works. But what you're going to want to make sure you have in front of you is you're going to want to make sure you also have these notes printed off and you have that available, because we're going to basically be doing an investigation today to really see what the rules are of A, H, and K. We're looking at this new equation. You started already by looking at standard form. So the form we're going to look at now is called vertex form. And in my opinion, it's much easier. But you have to know what A is doing. You have to know what H is doing, what K is doing. So instead of me just telling you, I wanted you to be able to investigate. So you're going to investigate by doing a Desmos activity. So if you go to student.desmos.com and type in our class code, EAAPC2, that'll bring you to our Desmos activity. It's obviously not going to be live, but you'll be able to do it at your own pace and follow along with the video as well. Okay? So press pause if you need a second to get logged in there, and then come back to the video. All right, so once you're into the video, this is going to be your first screen. And so what we're going to do first is start by looking at the value of A. What is the A doing? So just as a reminder, A is this guy right here. He's that value that's being multiplied in front of the parentheses. And our goal is, I want you to move our sliders. So these are sliders down here. Don't delete them. If you do, you're going to have to undo. But I want us to move our slider back and forth. And then I want you to make some observations as to what's actually happening to the parabola, right? So you can move it, you can see it's happening in real time. The smaller you make it, maybe the larger you make it. If you want to go, hey, where is it? You can move your window there, right? So move this back and forth and start to make some observations. What do you what do you think it's doing? And then once you think you kind of have an idea, it doesn't have to be even, anything great, just some basic stuff, then move on to the second slide. And what I want you to do is I want you to type in, hey, when does this parabola open down? So in this picture, it is opening down, right? When, if you have to go back, just go back to it. When was it opening down? Here it's not opening down, but here it is. So notice my values. As soon as my values went to something, then the parabola opened it down. It was opening up, it was completely flat, the parabola was gone, and then the parabola opened downward, right? So you want to make an observation. So take a second, type that into the second screen. When does the parabola open down? And then once you've typed it in, I want you to jump back on your notes here. And hopefully what you've recognized is you've recognized that the parabola opens down when A is negative, right? When A is negative, that's when your parabola is going to open downward. And that's what we want to put on the first part of our notes here. So I've got this covered up a little bit, and I can actually go this direction. So we're looking at, when is our parabola going to open down? Well, the parabola is going to open down. That's called a reflection. Okay, that's called a reflection. When it opens downward, it's actually reflecting, right? So yes, there is a reflection for that first one. If it's less than 0, so we have A is less than 0, that's when A is negative, then we're going to have this reflection happening, right? So what if it's between 0 and 1? What if it's between 0 and 1? So if I go back to my Desmos activity and I say, okay, when does it get narrower and wider, right? When is it going to get narrower and wider? Well, if we want to think about that, going back to the very first slide again, we can bring it back here, right? And we can say, hey, well, I don't know. I can't actually even get it between 0 and 1. So let's actually type in a number, right? So if you click right there, you can type in a number. Let's go with 0.5, right? Did it let me? There we go, 0.5. That looks interesting. If I go 0.9, that's a little bit skinnier. If I go 0.2, ooh, that's really wide, right? So what I'm noticing here is that the closer I get to 0, so let's go back to 0.9, then 0.8, then 0.7, then 0.6, then 0.5, then 0.4. So hopefully you're watching it happen here, that the closer we get to 0, the wider and wider our parabola is getting. So that's really what we're going for next, is we're trying to help us see that we're not going to get a reflection this time, but it is going to be really, really wide. Okay, so and then that kind of flows into when a is greater than 1. What happens when a is greater than 1? Well, if a ends up being greater than 1, we can get our slider back here. The bigger that number gets, you can see we're getting larger and larger and larger. The skinnier that parabola is getting, or the narrower and narrower the number that parabola gets. And that goes for negative values too, right? If it's reflected and then we go negative, it's also getting narrower, narrower and narrower. So the key here is to recognize that the closer we are to 0, the wider it is, and the further away from 0, the narrower we are. And then also the fact that there's a reflection. So A plays two roles. A plays the role of reflecting the parabola if it's negative, and then it plays the role of making it very, very narrow or very, very wide. And the only time it's going to be wide is if it's close to 0. The further we get from 0, whether that's negative or positive, is going to make it pretty narrow. So that's our first video. We really want to just focus on A and see what is the A value doing. So we're definitely talking about reflection and we're talking about shape. In the next video, we're going to look at the H value.